Okay. To reach on a specific destination, you guys are having a multiple path to reach out there. Okay. So in our case, what we do, okay, if you have a multiple path, okay, you will do what? Load balancing. You will do what? Load balancing. And that load balancing will take place, okay, in two different manners. In two different manners. One is known as equal cost load balancing, and the second one is known as unequal cost load balancing. Equal cost means what? When metrics are same, metric value. You guys know about metric? Okay, every different routing protocol have a concept of a metric to calculate the best path. What is metric? Metric is the calculation made by your routing protocol to calculate the best path. So every different routing protocol like EIGRP, OSPF, BGP and everything. Okay. Every routing protocol is having their own metric calculation method. Okay. So RIP use what? A hop count. To reach on a destination, it will calculate a hop count. Okay. From wherever it will get a least number of hop count, that path will be the preferred one to reach on that destination. That path will be used to reach on a destination. Okay, getting my point? Okay. So in equal cost load balancing, what exactly happens when you have a multiple path with a with a same metric value, they will by default do a equal cost load balancing. But in a different case, like if you have two number of hop count from above path and three number of hop count from bottom path, okay, in that case they won't perform any type of load balancing. They will only prefer the path which is shortest one, which is offering a least number of hop count. They will always prefer that path to reach on a destination. Okay, let me explain. Okay, here is your source IP address, okay, and here is your destination address. That means you want to reach on a destination which is connected behind your router 3 or 4, whatever it is. Okay, this is router 1, this is router 2, that is router 3, and that is router 4. The source address is behind the router 1 and the destination address is behind your router 3. Okay, so what you guys think? Which path will be the preferred path to reach on a destination? See, if you will prefer the above one, how many hops do you require? One, and the second hop is do. Here you required only two number of hop count to reach on a destination. Similarly, if you will prefer the bottom one, there also you need a two number of hop count. This is the one and this is the second one. Okay, to reach on any specific destination, you are getting a same number of hop count. In this case, what router one will do? Router one will perform an equal cost load balancing. What it will perform? Equal cost load balancing to reach on a specific destination. Okay, but in this case, let me add one more router over here. In this case, which path will be the preferred one? Anyone? Now from bottom, how many hops do you require? Here, from bottom, now you required a three number of hop counts. How many hop counts? Three. Router 1 will hop on router 4. router 4 will hop on router 5, and router 5 will hop on router 3. That means you required 3 number of hop count to reach on a specific destination. Okay, in this case, what router 1 will
Sorry,
do?
in this hop count, whether we will count one source near to source or near to destination.
Near to source or near to destination? What?
We are
Where?
counting three.
Huh? 3 number of hop
Uh,
count. Yeah, right.
yeah, we are leaving router 1 or router
No, no,
3.
no. See how it is calculated. Let me explain you first how it is calculated. Okay, this is the destination network which is connected on router 3. Am I right? Okay, router
Yes,
3 is the responsible to advertise that network through a rerouting protocol. Am I right?
right.
Okay, so what router 3 will do? Router 3 will advertise its own connected network, which is the destination one. Huh? Okay, it will advertise its network saying what I am having a network which is 1.0. Okay, and it is connected to 0 hop count. Why? Because it is a directly connected network of router 3. It did not require any number of hop to reach on 1.0 network. Am I right? Agreed?
Yes,
Does router 3 require any such hop to reach on 1.0 network? No. Why? Because it is a directly connected to router 3. Okay. Now, when advertising by router 3, it will advertise on every interfaces which is a participant of RIP routing protocol, which is a participant of RIP routing protocol. That means it will advertise over here. Also, it will advertise over here. Okay. Router 2 will receive that information. Router 2 will receive that information. Okay, my neighbor says they have a network of 1.0 with the hop count of 0, with the hop count of 0. But for me, it is not hop count 0. For me, it is hop count what? 1.
1.
For me, it is a hop count of 1. So what router 2 will do? Router 2 will store that information in its routing table, but along with what? Hop count number of 1. Similarly, router 5 will receive that information. Okay, exactly. Router 5 will receive that information and it will add in its routing table with the hop count of 1. Similarly, router 2 will advertise that network information to router 1. Okay, but while advertising that information, what it will advertise? A hop count of 1. A hop count of 1. Am I right? Agreed?
Agree, sir.
Okay, it will advertise to router 1. Router 1 will receive that information. It will kept in its routing table, but with how many hop count? 2. Okay.
Okay, okay.
Similarly,
Got it.
router. Hello, guys. Please keep your mic shut. It's very disturbing. Hold on.
अभी ये शकील चुप थे मिलियम मिलियम को तो सलाम दे रहा था पूरा सलाम कर बैठे
Okay. Router 3 will advertise that network information to router 5. Router 5 will store that network information with the hop count of 1. Similarly, router 5 will advertise to router 4. Router 4 will keep that information with hop count of 2. Router 4 will advertise that information to router 1. From router 1, it will keep as a 3. Now, you guys decide which one is the best one. 2 number of hop count or 3 number of hop count. See how the
3.
hop count
Sorry,
is
2.
being calculated. How the hop count is being calculated. Someone has asked this question. Okay. So like this, the hop count number is being calculated. Okay. Your means your advertised network. Okay. Your advertised router will advertise the number of hop count from its own router. Okay, and it will advertise with the hop count of 0. Then your neighbor router will receive that information and it will add what? 1, neighbor 2, neighbor 3. Okay. Now router 1 wants to reach on this subnet, which is 1.0. It will always prefer the path which is the above one to reach on a destination. Why? Because the bottom one is offering the higher number of hop count as compared to the above path. Okay. Getting my point? Now, in this scenario, what do you think? Does load balancing will take a place or not?
No.
Why no? Because the above one is offering
Yes,
the
sir.
least number of hop count as compared to the bottom one. So it will always prefer the above path to reach on a destination. Is it?
Yes.
Now, if your boss says the bottom link we have not taken in a free of cost. We are paying to this fellow also. We are paying.
Thank you.
Shit. Why you guys are not putting your mic off?
सऊदी में रखो ऐसे मौसम ने खत्म दुआ कर लेना
1 second ago. Okay, sorry guys. Okay, so in this topology, what I'm saying, so in this topology, they are going to perform is what? Unequal cost load balance. Why? In this scenario, you are going to forcefully send a traffic from this link also. Okay, if you are sending a forcefully traffic from the bottom path also, then it is known as unequal cost load balancing. What unequal cost says? Balancing a traffic using a multiple path when metrics are different. Okay, when you don't have this router, when you are not having this router, okay, that time you from both the links you are getting the same number of hop count. Okay, that means what? Equal cost load balancing. Balancing a traffic using a multiple path by having a same number of metric value. Any doubt regarding equal and unequal cost load balancing? You can ask me a question. Huh?
Yeah, excuse me, sir. I have a question here.
Tell me.
Can you please explain a cost and metric a little bit? Basically, it's making me confused. So, would that be possible if you can elaborate a little bit?
Cost you are asking? Metric you
Yeah,
are
cost,
asking, or
metric and
cost?
cost both. What exactly those things are, how exactly those works, and where exactly we are going to
See,
implement it. So
see,
how, what is the impact of cost and metric on network topology?
see, see. Okay. Shall I know? Okay. Uh, what exactly the metric term is? Metric term is an universal term in routing. Universal term. Okay. Every routing protocol calculate the best path. Calculate the best path according to its metric value. According to its metric value. As per RIP. As per RIP, metric is equal to hop count. A least number of hop count. Metric is equal to.
Hop count.
Okay. What is metric? Metric is the calculation made by your routing a protocol to find out the best path. Is it very simple to you? Okay. So it is a universal term. Metric you will listen in RIP. Metric you will listen in EIGRP, OSPF, BGP, and any of the routing protocol. Okay. Metric stand for what? It is a calculation made by your routing a protocol to find out the best path. Now what RIP use it? RIP use it what? Hop count. And what number of hop count? Least number of hop count. What it says? Least number of hop count. Okay. Secondly, in EIGRP, what is metric? Anybody? What is the metric value of EIGRP? How EIGRP calculate the best path? According to its metric value. Now, what is metric value of EIGRP? Anybody? Guys, you guys have already learned about the EIGRP. Tell me, it's a basic question.
So
Waiting for you guys.
EIGRP, we can adjust bandwidth, delay, yeah, I think bandwidth and delay.
For what exactly it is known as? The name.
You mean my name? My name is John.
No. I am not asking your name, man. Bandwidth, load, delay, reliability, and MTU. Okay. If you
Yes,
will make
yes.
all the bundle of it, okay, what it is known as? Bandwidth, you said, na? Bandwidth, delay, load, reliability, and MTU. They are going to see 5 different values. 5 different values. Not like RIP. RIP is very simple in metric. It will only justify with the help of hop count. Okay, but in EIGRP, they are going to use bandwidth, delay, load, reliability, and MTU, BDLRM. K values. Anybody for OSPF?
Sir,
Anybody?
cost.
For OSPF cost. Okay, let me differentiate it. Okay, what RIP says, my metric value. Metric value means what? My calculation is what? A least number of options. Okay, EIGRP say my metric to calculate the best path is known as what? Composite metric. Composite metrics carry bandwidth, delay, load, reliability, and MTU. How it will calculate it? That I will see in EIGRP. Okay. Next one is what? Metric, OSPF. Metric calculation to find out the best path is what? Cost. Is what? Cost. How it is calculated? That we will see in OSPF. Okay. So now who asked this question? Metric is equal to metric. What is metric and what is cost? Okay. So metric is a universal name. Okay. To calculate the best path, they have given you a name known as what? Metric. Okay, every different routing protocol have a different condition to calculate it. Okay, so cost is nothing. Cost is what? A metric value of your OSPF. 10 raised to 8 divided by bandwidth. Is it? Okay. EIGRP metric is equal to what? Composite metrics, which have what? Bandwidth, delay, load, reliability, and MTU. RIP metric is equal to what? Hop count, a least number of hop count. That is the preferable path to reach on a destination. Okay. So metric, so cost. Okay. Don't be get confused and don't make others confused. Metric is the different thing and cost is the different thing. Metric is the calculation. Okay, and cost is the calculation. Okay, for OSPF to find out the best path. Cost is the calculation. For OSPF only, not for EIGRP, not for RIP. But metric, you will see a universal name with every different routing protocol. Now understand? Who asked this question? Understand that? Bro?
Yes, sir. Yes, sir.
Okay, so don't be get confused. Metric is the different thing and cost is the different thing. Any question regarding this now?
No,
If
sir.
you have,
It's clear.
no. If you have any question, ask me again and again. I am there to clear it. Okay, so now we are on a RIP. So we will discuss about the RIP. RIP metric value is equal to what? Hop count. What it will see? It will see the least number of hop count. Wherever it will get it, that will prefer to reach on a destination. That path will be preferred to reach on a destination. Okay. So similarly, in this topology, wherever it will get a least number of outcomes, that path will be preferred to reach on a destination. Okay. Any doubt? How to remember all this? How to remember? That you have to remember, bro. Is Mujahid. How to remember all this? You have to remember how I remembered. I am not using any notes for any of the routing protocol. I remember each and every features of every routing protocols. Okay, so you have to make a practice on every daily basis. Then only you will remember. If you will open a book today and after that, after a 1 year, okay, you won't remember anything. How you remember the calculation of subnetting them? Subnetting calculation is very difficult to remember. These are the just features. Any other feature? What you guys said? Routing a protocol, distance vector routing a protocol, distance vector. Distance vector. What exactly the vector means? To capture something. Okay, it will capture the distance in the form of hop count. That is why they are known as distance vector routing a protocol. We have similarly we have what distance vector routing a protocol. One is other one is what? Anyone? What are the different types of routing a protocol? Distance vector routing a protocol. And the second one is what?
Link state.
Link state routing a protocol. Very good. And the third one is what?
Advanced distance.
Advanced distance vector routing a protocol. Okay. And the fourth one is what? Yes? Huh? No, I didn't hear you.
Path vector.
Path vector protocol. Who is it?
Sir Deepak.
Huh?
Sir BGP.
BGP. Very good. Okay. BGP is purely path vector routing a protocol. OSPF is purely link state routing a protocol. RIP is purely distance vector routing a protocol. What about EIGRP? EIGRP is distance vector, link state, path vector, advanced distance vector routing protocol. What exactly it is?
Advanced distance.
Advanced distance vector routing a protocol plus link state routing a protocol. That is why it is known as hybrid routing a protocol. What it is known as? Hybrid routing a protocol. Hybrid. Okay, hybrid means what? A composite a hybrid of distance vector, so advanced distance vector and link state routing protocol. Okay. Second one, it says open standard protocol. All of you know. Okay, RIP is an open standard routing protocol, means you can run this routing protocol on any vendor routers. It can be your Juniper, it can be Cisco, it can be any. Okay. It supports up to 15 number of hopcon. How many hopcon does it support? Up to 15 number of hopcon. Okay, that means it is designed for small area network. 15 small area network. It is not for a large enterprise. Why? Because it supports up to 15 number of hopcon. 15 means what? 1, 2, 3, 4, up to 15. Okay, if any network which is connected on the 16th hop, that will become unreachable for your router. That will become unreachable for your router. Okay, guys. Next, equal cost load balancing. You guys have already seen. Unequal cost load balancing. You guys have already seen. Any doubt in equal cost and unequal cost load balancing? Okay. Unequal cost load balancing, which is not supported by your RIP routing protocol. RIP routing protocol does not support any unequal cost load balancing. It will only support equal cost load balancing up to 16 equal cost. Up to 16 equal path. It will support equal cost load balancing up to 16 equal path. 16 equal path means what? This is the first path. Okay, this is the second path. How like third path, fourth path, fifth, sixth, seven, up to 16 equal path. It will support a load balancing. For 17, it will say no, I am already full. Okay. So equal cost load balancing supported up to 16 equal path. And default is what?
4.
Default is 4. Very good. Very good. Very good. Okay. It will support up to 16 equal path, and the default value which is configured under RIP is what? 4. If you want to extend it, you have to use some command to extend it. Maximum path. That is the simple command. Maximum hyphen path. And you can extend up to 16 number of hopcon. Okay. Any more feature regarding the RIP routing protocol? Support authentication. What is authentication? What exactly the authentication means? To authenticate someone before exchanging any information. ENCOR. What authentication? What does authentication mean? Login and a password. No. It is not a login and password. Okay, authentication means by default we say login and password. Okay, but we are learning a routing, so you have to answer something technically only.
Authentication proves the identity.
What?
And that's to prove identity.
To prove the identity. To prove the identity. Okay. What exactly the authentication means? To prove the identity. That means before exchanging any information with your neighbor router, you have to prove the identification. You have to prove the identity. Okay. So to exchange the authentication, they have two different formats. Okay. And what are they? What are the different authentication in routing a protocol? Anyone? Somebody said something. Big authentication. Very big answer.
Chap.
Pap and chap. Pap and chap. Chap. Who is chap? Pap and chap we use for in point-to-point link, that it is different. This is a routing a protocol authentication, PAP, password authentication protocol, and challenge handshake authentication protocol. Right? You are asking for the same?
Yes, sir.
No, that is a different thing. That is a different thing. PAP authentication and CHAP authentication, challenge handshake. Here we are talking about the simple authentication and MD5 authentication, message digestify authentication. Okay,
So
you're
plain
routing a
text.
protocol, plain text, which is simple text, simple text, simple
Okay.
authentication known as plain text, simple authentication, similar. Okay, someone says plain text, some says simple text. Okay, so that is not a different than the simple authentication. Same thing, plain text and simple text authentication. Second one is what? The secured one, which is known as what? MD5 authentication. Known as what? MD5. MD5, which is message digestify, which is what? Encrypted. Which is what? Encrypted. Okay. Simple authentication is what? Which is simple in text, which is also known as what? Plain text authentication. Plain text authentication. Zahid, mute your mic. Okay. So one is what? A simple authentication, which is a plain text authentication, and the second one is what? MD5 authentication, which is encrypted. Okay. While exchanging authentication information, while you are authenticating to your neighbor router, okay, the username and the password, whatever you have configured, that should be exchanged in a plain text format or in encrypted format. Okay, that you have to decide by using one of them. If you will use the simple authentication, it will be in a plain text while exchanging those critical information. Okay, you are exchanging in a simple format. Okay, if you are using an MD5, okay, if you have enabled an MD5 authentication, okay, that information will be what? Encrypted. That information will be what? Encrypted. Now, RIP use MD5 authentication or simple authentication? What kind of authentication you can enable in RIP routing a protocol? Okay, so both are supported. Both are supported. Version 1 only simple authentication is supported, but in version 2 it supports simple as well as MD5 authentication. Both it is supported in RIP routing version 2. RIP version 2. Okay. Any more point?
Sir, one more authentication is there, right? SHA.
SHA authentication, which we used on VPN to for VPN and all. Not over here, not in your routing
Okay.
info. There SHA authentication, which is for IPsec protocol, Internet Protocol Security Protocol, and IPsec, which is used to form a VPN connection, VPNs. Okay.
Sir, in routing protocol, you told us 4 authentication types, like it's PAP and CHAP and simple and
No,
MD5,
no,
right?
no. No. PAP and CHAP is not for routing, not for routing. That is for link. Okay. When we used to have a frame relay, did you remember about the frame relay? A very old technology, frame relay. Okay, there we used to configure this PPP point-to-point protocol. Do you know about the point-to-point protocol?
Yes, sir.
Yes, sir.
Okay, in point-to-point protocol, we use our authentication type CHAP and PAP, where CHAP is a preferred one as compared to PAP. In PAP, similarly, same PAP, simple authentication, CHAP, which is challenge handshake authentication.
And what about
Okay.
the routing
So for
protocol we use for the routing protocol? It's
second,
simple or MD5.
In
If
routing the protocol, we use the simple authentication and MD5 authentication. Okay.
okay,
So what?
okay, sir.
In routing the protocol. So In RIP routing, what exactly they use? Charging.
So simple and MD5, as you told you earlier.
Simple and MD5. RIP support both. Okay, version 1 which only support a simple authentication, version 2 which support a simple as well as MD5 authentication. Okay. Now, any more features? What a RIP routers exchange with its neighbor router? What it exchange?
So routing table.
Full routing table. Okay. A router will exchange. That means router 1 will exchange to router 2 its complete routing table. It's what? A complete routing table. Router 1 will exchange a complete routing table with router 2. What router 2 will do? Router 2 will exchange a complete routing table with router 3 and router 1. Okay. Similarly, router 3 will exchange a complete routing table with router 2. Okay, and vice versa. Okay, but when it will exchange?
In every 30 seconds.
Updates are exchanged in every
30
30
seconds.
seconds. That means what? They have periodic updates. This is known as what? Periodic updates. After every 30 seconds of a period, okay, they will exchange a complete routing table with your neighbor router. That makes your RIP routing protocol to perform slow. To perform what? Slow. In every 30 seconds, they have to exchange a complete routing table with its neighbor router. Okay. And updates are sent on what address? How they will exchange the updates? In version 1, they will broadcast it. They will broadcast it. Version 2, they will what? Unicast, multicast, broadcast, anycast.
Multicast.
Multicast it. Multicast it. On what address?
09.
Very good. 224.0.0.9. Now, what exactly does it mean? Broadcast, multicast. What broadcast means? Broadcast means what? Send to all. Whoever is connected, they will accept it. Why? Because it is in broadcast packet. What multicast means?
I have a question. Updates are exchanged in every 30 seconds. So these updates are routing table, or there are something else
Complete
they
routing
exchange?
table. Complete routing table in every 30 seconds.
Even though there's a change in the routing table or not, but they keep going to exchange with them.
Keep going on. In every 30 seconds, full routing table. Every 30 seconds, complete routing table. If there is a change or not, they will pick a period of 30 seconds. Okay, that is the reason here. What exactly happens? If you have two routers, okay, you have configured a RIP between them. Okay, once you will configure a RIP between them and they have become a neighbor, a clock start of 30 seconds. A clock start of 30 seconds, and it keep reducing like 29, 28, 27, something. Once it will come on 0, okay, they will exchange a complete routing table to its neighbor router. Similarly, from router 2 also, same thing. Now suppose your clock is on 25. For example, I am saying clock is on 25. It will keep reducing. Okay, from 25, it will come on 24, 23, 22, 21, like this. Okay, your clock is on 25. See it carefully. And one of the network of router 1 goes down. Okay, one of the, who is this? Bilal Ahmed. one of the network of router 1 goes down. Down means what? It is no more reachable. It is no more reachable. Okay. Then also router 2 will generate a traffic to reach on that destination which is not reachable. Which is not reachable. After completing of a 25 second, after completing of 25 second, router 1 will inform to router 2 that this network is no more reachable. This network is no more. How it will send a specific information that this network is no more reachable? No. This fellow will send a complete routing table without having this network information. Router 2 will accept it and it will see 1.0 is no more. Then router 2 will stop sending a packets on router 1 for this network. But for next 25 seconds, they are keep on sending. Why? Because router 2 does not have that information. That is the drawback of your periodic update. The update should be every time. Every time the update should be what? Incremental update. Whenever any increment happens, immediately inform to your neighbor router. That is the feature of your increment update. Okay. Whenever this network will goes down within a second, without wasting a second, okay, router 1 will immediately inform to its neighbor router a failure of a network. Router 2 will immediately updates its routing table and it will say no more 1.0 network or whatever the network is. Got the point? Yes. Someone is asking something. DSL. DSL. Yes, Mujahid, what is DSL?
Sir, I have heard that router does not broadcast.
Router
Does not broadcast any traffic.
broadcast? No, I didn't get you.
Sir,
Router?
router never broadcast. I have heard somewhere router never broadcast.
Router never broadcast. Yes, router will never broadcast. Your routing information is getting broadcast. By default,
Just
router will never
think
broadcast any information. My volume is getting break or your volume? Hello?
Sir, perhaps mine.
it seems that your internet connection is not stable.
Mine one?
Yours is fine. Yours is fine.
No. I can hear you, sir. Fine.
Okay. Explain multicast. Yeah, I will explain. I will explain the multicast. Don't worry. Where we on? We are on update packets and all. Okay. Now the point which I defined here is updates are sent on broadcast, and the second one is what? Updates are sent on multicast. Now what exactly does it mean? Deep routing a protocol always version 1 will always broadcast its information to its neighbor router. It will always broadcast its information to its neighbor router. That means whoever is directly connected to your router, what it will do? It will always broadcast that information. Okay, it won't check whether your neighbor router is configured for RAID or any other routing protocol. What it will do? It will just broadcast. And you know the result of a broadcast. Okay, similarly in version 2, what it will do? It will only multicast that information. If your neighbor router is configured for version 2, RIP version 2, then only it will be able to receive that information. That only it will able to receive that information. Once you will enable RIP version 2 on your router, once you will enable the RIP version 2 on your router, by default they will enable this address 224.0.0.9. Okay, so while sending on both the router, they will enable address of 224.0.0.9. While sending a update packet from version 2, it will only send to whom? 224.0.0.9. If your neighbor router configured for RIP version 2, enabled with an IP address of 224.0.0.9, router 2 will able to receive that information. But in the case of version 1, in version 1, nothing like that. Version 1, it will send a information on broadcast address, and broadcast is for everyone. Broadcast is for everyone, whether your neighbor router is configured for RAID, PIGRP or OSPF. They are able to receive that information. Got this point? Yes. Now your turn. Questions? No questions? Any more features of RIP? Did you guys remember about it in CCNA? Am I audible to everyone?
Yes.
Yes, okay. Any more features?
AD value is 120.
Huh?
AD value.
AD value. Very good, very good. Thanks for remembering. AD value is what? 120. Now, if you will compare in this topology, if you will run RIP routing a protocol as well as static routing a protocol, to whom your router will give a preference? Your router will give a preference to static routing a protocol. Why? Because static routing a protocol default is having a one administrative distance. Okay, so your router will prefer the static routing protocol compared to RIP routing a protocol. Okay. Now, what are the commands to configure the RIP routing protocol? Simple way. Router RIP. One more point. Version 1 is what? Classful. And version 2 is what?
Yes.
Classless. Okay. And you guys better know the difference between classful routing protocol and classless. Classful, which do not carry any subnet marks along with the network ID. And classless will always carry the actual subnet marks while advertising the network ID. Yesterday only we have seen this. What are the commands to configure the RIP routing protocol in the topology on the router or anywhere? Did you guys practice the static routing protocol or not? Tomorrow we will have a session for practicals. Huh? Tomorrow, Friday. We'll have a session for practicals. We will do a practicals of static as well as this one, RIP also. The commands to configure the RIP routing protocol is what? Router RIP. Then after that, you can define the version 1. If you want to use a version 1 or version 2, then no auto summary. What is auto summary and no auto summary? Auto summarization and manual summarization. Summarization, what exactly the summarization means? Anybody?
Doesn't it compress the IP addresses in the network to a smaller one?
What such IP addresses? If you have an IP of, for example, if I will say one IP is like 192.168.10.1, and the second one is 192 or 172.16.1.1. Okay, are you able to compress these two IPs? Yes. Are you able to compress or bundled these two IP address?
I don't think so because they are two different 192 and 178. So I think in my understanding, if we're to compress 192, you can just do it 192.168.10.0 and then 172.16.1.0. Yeah, you can correct me there.
Okay. Okay, you won't be able to compress these two values. Why? Because they two are not similar networks. Okay. So what exactly the summarization says? Summarization says bundling of one or more similar network, bundling of one or more similar network and advertising as a single network. And advertising as a single network is known as summarization. Bundling of one or more similar networks. Okay. And
So similar in the
advertising
sense of class.
similar in the sense of, see, let me explain. 192.168 10.1, for example, 192.168 20.1, 192.168 30.1. Second one is 193.168 40.1. Okay. Now, can you please tell me which are the similar networks over here? By looking on it, like 192, 168, 10, three of them octets are same, third one is same, second one is same, third one. But if you will see the fourth one, which is dissimilar, this does not belongs to a subnetworks of 192. Is it or not? This does not belongs to a network, subnetwork of 192. Similar network you can define, how you can define is, did you guys have already done the subnetting, right? Subnetting. In subnetting, what you have done, you have created a single network, a single major network into a multiple small networks. Did you remember?
Right.
You have, right or no? You
Right.
you guys have created a multiple small networks while using a single major network, big network. Okay, so those multiple networks, multiple sub networks are known as what? Similar networks. Why? Because they comes from a single network. Okay, they comes from a single network. That is why they are known as what? Similar networks. So similarly here also, if you will see, okay, what do you think? 192, 168, 10, 20, 30, they all comes from a same networks. Okay, but if you will see the fourth one, 193.168, this does not belongs to your that big network, the major one. Am I right? Okay, so they are not in a sequence. They are not in a sequence of similar networks. Okay, you have to remove this one. Now this three has become what? A similar network. Now you can do what? You can compress these values. You can compress this value. It's simple.
Sir,
It's
sir,
an
take
opposite
one
of a
more IP.
subnetting.
Sir, take one more IP. 192 10.30.1.
10.30.1. What do you say?
Does it come under similar?
No, no, it will also not come under similar network. Then how you have done a subnetting? What tell me? You have done a subnetting something like this 192.1.0.0.0/8. Have you done the subnetting like this? If you have done a subnetting like this, okay, these all four networks will come into a similar network. Bro, let me tell you one thing. Subnetting is very important, very much important in networking. Subnetting is very much important in networking.
Can I have one class on subnetting?
Subnetting, we can't complete in one class. So for subnetting, at least you required 4 number of classes, 4 classes, and 2 hours each. Subnetting is very vast to make someone understand. See,
At that
I
time,
have
at
a
the time of
experience
reading,
of,
we able to understand these things, but later on, I forgot.
see, I have a experience of 12 years in industry. 12 years in industry. Every day, we guys are doing this part, like configuring IP, assigning of IPs. Okay, and every day we recall the subnetting. Every day. Okay, so subnetting you are going to use till the death if you are working. Okay, so subnetting, which is it's play a very important role in networking. No? So do recall your subnetting, work on subnetting. Okay, that's what I can say now.
But if possible, one class.
In one class, it is not going to be completed. In one class, I can't explain you everything about the subnetting.
Sir, we know subnetting, but thing is that I forgot.
So recall it, bro. Recall it, please. Okay, next is what a summary. So by default, RIP version 1 and version 2. Okay, by default, they do a auto summarization. So we forcefully stop it by using a command no auto summary. Okay, next command to advertise your connected network. Okay,
Sir, what
this is
does
network.
auto summary like? What exactly the role of it?
What exactly the role of it? Okay, see here. If you have if you have multiple similar networks, what router one will do? Router one will automatically summarize all the networks and advertise it to router two. Okay, for example, here you have a network of 172.16.1.0/24. Okay, again you have 172.16.2.0/24. Okay, again here you have 172.16.3.0/24. Okay, while advertising this network from router 1 was run. Okay, what router 1 will do? Router 1 will automatically summarize all these subnet, three subnet into one network and advertise to router 2 On router 2, if you will see, only one network, which is 172.16.0.0/16. You will see only one sub network, which is 172.16.0.0/16. Okay, auto summarization, which is very like disadvantage in your network. Yesterday I given you one more example, like if you have one more subnet over here, which is 172.16.4.0, which is critical in your network, and you don't want to advertise this network to any of the router. Now what do you say? Will this be able to hide with router 2? Will this network be able to hide with router 2 with the effect of auto summarization? No, it won't be able to hide. Why? Because your router by default performed the auto summarization, and now router 2 is able to reach this network. So
So like
always make sure.
it will hide 172.18, sir.
17. Oh, that's my mistake. Okay, but it is 172.16. Believe it is 172.16. Okay.
Okay.
Okay. So this is very harm to your network. So always make a habit to run this command no auto hyphen summary in RIP, in EIGRP, both. EIGRP also by default support auto summarization. Then to advertise your network, what you will use network, and whatever the network you have configured on your router, that will be your network ID. Yeah? Network and network ID. Clear? RIP routing.
Sir, but there is no subnetting information.
There is no subnetting information. Means Subnet marks information.
Yes,
Subnet marks information you are asking, right?
right, sir.
Okay. In RIP, we do not advertise the network ID with a subnet marks. In RIP, you have to
Then, sir,
advertise
it will be,
the.
sir, classful, sir.
No. It is classless. If you are using
How?
version 2, if you are using version 2, it will be classless. Okay. If you are using version 1, it will be classful. That we will see tomorrow.
For class version 2 also the commands remain same, sir. There is no subnet.
No subnet. Version 2, no subnet. Version 1, no subnet, nothing.
Then how it will be classful? One is classless.
What is version 1 and version 2? If you are running version 1, it will be classful. If you are running version 2, it will be classless. Okay, if you are running version 1, okay, it will carry the actual subnet marks, whatever there in your routing table. It is not dependent what subnet marks you are advertising. Okay, well, from where it will collect the subnet marks information from your routing table, man. Got it?
Okay, got it.
It will not collect the subnet marks information while advertising it. Okay, it will collect the information from your routing table. In your routing table, you stored the directly connected information. Okay, but if when it is classful routing protocol, it will take the information from your routing table, but without the subnet marks. Without the subnet marks. If it is version 2, it will take the information from routing table, but with the subnet marks. Got it, everyone? Tomorrow we will have a practical session for static and RIP routing of protocol. Any doubt regarding the same? Hope everyone get it. Okay. Thank you,
Please,
everyone.
Thank you.
Thank you.
Okay. Just a quick one. With the EXRP, will we be diving deep into the metric composites? How a composite
how the composite
yes.
How composite metric works, you are asking?
Yes. Will we be doing that as well?
Yeah, we are going to do it. We are going to do it. Bandwidth, load, delay, reliability. I will define you each and every value.
Okay. Okay. Thank you.
Okay. Thanks, everyone. Hope tomorrow we
Yes,
will
sir.
meet
Good
at the
night.
same time. Good night.
Good night.